In this video, we're going to recall how to do significant figures in logarithms. So the rule says that the number of significant figures in the mantissa is equal to the number of significant figures inside the log. So for instance, if we take the log of 54.2, the answer is 1.733. We need the number of significant figures in the mantissa, which are the numbers after the decimal place, to be equal to the number of significant figures in the log. So we have 3 significant figures in the number inside the log. That means we need 3 significant figures in the mantissa. The characteristic refers to the number that comes before the decimal place, and you don't need to worry about it when it comes to significant figures. If you want to find the antilog, so you want to take 10 to something, you can say that the number that you're taking 10 to the power of, these digits, the digits after the decimal place are the mantissa, and so this has to be reflected in the number of significant figures in the final answer. So here there are 2 significant figures in the mantissa. If you take 10 to the 2.56, you end up with 363, but we can only have 2 significant figures in our answer, so we'd have 360 or 3.6 times 10 to the 2, okay, to be more correct. And so we need to be careful, especially using the antilog. Sometimes you can forget what the mantissa is, but it's just the number after the decimal place. So let's look at what this looks like in terms of pH. So let's say we have a proton concentration of 3.39 times 10 to the minus 3 molar, and we want to find the pH. So we'll take the minus the log of that concentration, because pH is equal to minus log of the proton concentration, and we'll end up with a number 2.4828. Okay, so we have three significant figures in the number in the log, which means we need 3 significant figures in the mantissa of our answer. Okay, so we'll need 3 significant figures here, and so we would end up with pH equals 2.483. Okay, we're rounding up on that last decimal place.